Well, guys, today you had your quiz. Hopefully you all did well on that. This is the video right after. This is actually try number 2. I did a whole recording and then it was screwed up. So this is the second attempt. First thing, we're going to introduce you to lines today. A few things. It's a lot more just notation and definitions. First thing I want to talk about is a relation. A relation is a pairing of input values with output values. Remember, input were like our x values, and outputs are like our y values. We kind of talked about that with the roof problem on the absolute value day. So there's different kinds of relations. You can have them as an ordered pair or a point. That's another word for it. You can have a mapping where it says 1 can give you a 7 or a 10, 0 gives you an 8, -1 gives you a 9. Or you could have a graph, and that can show you the age. In this case, it'd be age and height for basketball players. And it's just plotted. So your input would be your age, your output would be your height. Okay, so that is what a relation is. A domain is the set of all inputs. The notation we're going to use for this class, and usually it'll be x, so it'll start like that, and then we're going to write our domain there, and then we close the bracket. We do the same thing for range. The range is the set of all outputs or answers, our y values. The notation for range would be r, such that they are the y values, and then you have to figure out what y is. Okay? And then what a function is. Definition of a function is important. This will carry through with the rest of your pretty much math career. A function is a relation in which for every input there is exactly one output. So if we look back at the top ones real fast, the first one's actually a function, because if you say I have an input of 4 for my x, how many outputs do you get? You get only 5, the number 5. Even though it happens twice, it doesn't matter. If I look and say x is 3, what's my output? I get 5, so that's a function. This second one, the mapping, is not a function, because if I say I know my x is 1, what are my outputs for 1? You get 7 and 10. That's two different ones, not a function. Another way I like to think about it is if you want to go to the vending machine and you go get a Mountain Dew, and you hit the Mountain Dew button, you would expect it to give you a Mountain Dew. That would be a function. That button always gives you a Mountain Dew. However, if the person loaded the machine wrong and you get a Diet Coke, which I don't know how that would happen because it's a Pepsi product, but if you get a Diet Coke, then that would now represent not a function because you pushed the Mountain Dew button and got something different. Okay? So how do you know if something is a function? Basically, you just look at it if it's one of those mappings or points. Another way is the vertical line test. So you can draw a vertical line. Draw a vertical line, and then if it touches twice, then it's not a function. Okay? And again, that's because if it touches twice, that means that there are two outputs for that x value, because a vertical line is an x value. So if I said x equals -1, I'm going to put that there. I'm going to draw a vertical line. If I said x is -1, you would tell me, oh, there's two outputs, one here and one here. You can't have that for a function, so it's not a function. B is a little weird just because it's a piecewise graph, and you guys are going to see that in a little bit. But the only problems that you might have are here and here, because if you draw a vertical line through them, you hit two things. However, since this is open, there's nothing there. So really you're only hitting one thing here, and you're only hitting this thing here. You're only hitting those two things. Therefore, this is a function. And finally, this clearly is a function because you don't have anything else hitting there except for one spot. So that is what a function is. One output for, if you have, there's only one output for every input. Okay. Dependent and independent. Linear. Y equals mx plus b. You guys should remember that from, that's what we're doing this all in the video. Some of this stuff should be review. This is dependent on the other variables. It's also your output, and I've already talked about that. And output in general is the y variable. The independent variable, though, just goes into the equation. So that means it's your input. And in the equation y equals mx plus b, usually we input the x value. Okay? Function notation is just a notation. The stuff on the left does not mean you're multiplying f by x. This is just another way to write the letter y. But it's better because you can see what you're putting in. So this is saying, if I want to know the function at some value, this is what I do. So for f of 5, I'm going to say I want the function when x is 5. Well, when x is 5, this is what you get over here. So the function when x is 5 is evaluated, and I believe this is 26, 39, or 35 minus 20, or minus 9. And that's all you do. So that's all that means. Y equals 26. So if you didn't have f of 5, you would just have y and you plug a 5 in and you still get 26. So nothing changes except for the notation. Alright, we got a little bit more. Slope. You guys should remember slope from Algebra 1. It's the ratio of the change in the y, or output values. Actually, let me do a slash there. Y, or output values. And the ratio of the change in that to the change in x, or input values. Okay? X, or input values. Or distance. That's the formula over there. You guys should kind of be familiar with that. And finally, well, almost finally, we're going to classify by its slope. So if it has a positive slope, it would go up and to the right. Okay. An example of that would be y equals x. Well, and that's kind of what I drew. A negative slope would go down and to the right. This could be y equals negative x. A zero slope means that it's not rising, because remember slope is rise over run. And if you have a 0 on top, that means you have a 0 for the fraction. Which means that we have a horizontal line. So a zero slope is something that you can stand on. It exists. The slope exists. It's 0. It's a horizontal line. You get y equals a number. So a constant. We're just going to say 4 here, or something else. That's an example of a zero slope. An undefined slope, on the other hand, would be x equals, because you only have a rise, you have no run. So x equals 4 is an example of a vertical line equation. Okay. All right. Parallel lines, lines that have the same slope. And parallel lines, we usually kind of just draw two lines that are parallel, and they're longer than usually the problem. Perpendicular lines, lines with the slopes that are opposite, reciprocals of each other. The symbol we use for a perpendicular is that. Another thing you should know about perpendicular lines, the product of the slopes will always equal, and let's see what it is. So if I tell you I have a slope of 2/3 and I have another slope, the perpendicular slope of that would be flip it and change the sign. What happens when you multiply those two together? You get 2/3 times -3/2. You get -6/6 or -1. And that'll happen every time. You get -1 when you multiply two perpendicular lines for their slopes only. Okay? And finally, we're going to do 3 quick graphs. You guys are going to learn more about these actual equations tomorrow. But for now, we're going to just do a quick graphs. This first one you should be familiar with. This is slope-intercept form, where m is the slope and b is the y-intercept. And again, the coordinate is 0, b for that. So for this problem, we have a point 0, 4 and then a slope of -3/2. So I'm going to go up to 0, 4, and then all you do is move with the slope, kind of like we did with the absolute value graphs. So the top is rise, so we go up, or it's actually negative, so we're going to go down 3 and then over 2, because it should, 1, 2, 3, go down and to the right. I like to put as many points as possible just to be as accurate as possible. So there's my line. I draw it, and there it is. Okay, so that's slope-intercept form. You're also going to be learning the other two forms, and actually this is a very important form. Point-slope form is the one that you're going to start with every time. And it's pretty simple. The slope is still m, so we'll put that in first. And then you will have any point. It doesn't have to be the y-intercept. And the point will just be x1, comma, y1. So in this case, and notice that the point is always opposite of the value. So for this problem, we have a point at an x of -1, remember that's opposite, and at a y of 3. And then our slope is 2/3. So you start at that -1, 3 point, and you go up 2 and over 3. And again, it's positive, so we're going up and to the right. And down and to the left. And there it is. And then we can connect all the dots. You can use usually what people do on these, they use their IDs. Usually the graphs are perfect size for those to make straight lines. Try to make them as straight as possible. Standard form, we use the cover-up method, or we use the set x equal to 0 and then set y equal to 0. It's two separate things. So when x equals 0, this goes away and we're left with -4y equals 12, or y is equal to -3. So you get the point 0, -3. When y is equal to 0, you get 2x equal 12, x equals 6, and the point 6, 0. And when you have the 2 points, you only need 2 points to sketch a line. So we plot 0, -3, and 6, 0, and then we sketch the line. And then we're done. And that's all I need to see for standard form. Set each letter equal to 0, solve for y and x, and you get your 2 points, connect the dots. And that is an intro to lines. Again, we'll learn about more about these three forms in class tomorrow.